So, what's the most dangerous idea in all of mathematics? No, it's not a cursed equation that summons demons. It's not even long division. It's zero. Yeah, that little oval. That nothing. The number that isn't a number. The thing you get when you forget your PIN code 3 times and your bank account resets to its natural state. Tonight, we're going to talk about how zero, yes, zero broke reality, and then, somehow, fixed it again. But first, let's get comfortable. You don't need to understand math. You don't need to remember any formulas. You don't even need to stay awake. I'll do the thinking. You just lay there and listen to a long, soft story about nothing. Literally. Now, zero seems harmless, right? It's just there, hanging out at the end of a phone number, or taunting you when your favorite snack is out of stock, or when you finally check your bank account after a vacation and see, yeah. But the story of zero is anything but boring. This is a story about ancient fear, forbidden knowledge, banned symbols, mind-bending ideas, and people who are willing to risk everything for nothing. And I mean that quite literally, because for most of human history, zero was not just ignored, it was feared, hated, denied. People would rather live in a world of confusing numbers, ridiculous math, and broken systems than accept that nothing could be something. It took thousands of years, several civilizations, a handful of geniuses, and some very confused philosophers to let the number zero exist. And tonight you're going to hear that entire story, but not too fast, because this isn't a race. It's a sleepy walk through the foggy garden of mathematical history, a place where ancient scrolls are covered in dust, and every candle flickers gently on the edge of discovering absolutely nothing. Let's start with a simple idea. Imagine a world without zero. How would you write the number 10? Well, without zero, there is no 10. There's just 1, then 11, then 12. You don't have placeholders. You don't have decimals. You don't have negative numbers. You don't even have the concept of nothing as something that can be written down. That's how most early civilizations lived. They could count sheep. They could count fish. They could even build pyramids. But when it came to saying none, they didn't really have a word for it. Or a symbol. Or a clue. They were like 3 sheep, easy. 2 sheep, of course. 1 sheep, got it. No sheep? Just don't write anything. 0 was just silence. Now, here's the twist. Even though they didn't have a symbol for it, they still experienced it. If you owed someone 4 chickens and only had 1, congratulations. You were already living in a zero-based economy, but mathematically that was just described as a problem for future you. You see, early humans were very practical. They didn't invent math to feel smart. They invented math so they wouldn't starve. They needed numbers to count food, to measure land, to trade goats, that kind of thing. But for a long time, zero wasn't useful, because you can't trade nothing. You can't divide a field into 0 parts and expect to keep friends, and so most civilizations just kind of skipped it. In fact, some of the earliest number systems didn't have a symbol for 0 at all. The Egyptians? Nope. The Greeks? Not really. The Romans? Absolutely not. Which, by the way, explains a lot about how awful Roman math was. Have you ever tried doing multiplication in Roman numerals? Try multiplying LXX8. I'll wait. Actually, no, I won't. Because it's terrible. There's no 0. There's no place value. There's no decimal system. Just a lot of confusing letters and very stressed out scribes. And when someone finally did try to bring up the idea of 0, people didn't say, "Oh wow, what an elegant and useful innovation." They said, "What? A number that means nothing? That sounds like witchcraft." Literally. In some places it was considered dangerous or even blasphemous to use 0, which, when you think about it, is kind of amazing. Imagine banning the number nothing. Imagine being so uncomfortable with a concept that you just pretend it doesn't exist. People were okay with square roots, giant numerals, complex trade systems, but 0? That was a bridge too far. Because 0 isn't just a number, it's a statement. It says, there is an absence here. It says, something used to be here. Now it's gone. It says, nothing is a thing. And that messes with people. Especially in ancient times where numbers weren't just tools, they were symbols of order, of the universe, of divine design. If God created everything, how could nothing exist? If something had no quantity, how could it be? You see where this is going. 0 wasn't just a math problem, it was a spiritual crisis. And that's why 0 had to fight for its life, over and over again, across empires, through centuries, and inside the dusty corners of forgotten libraries. 0 waited. It waited to be discovered, to be understood, to be accepted. And when that finally happened, when a few clever minds in ancient India began to embrace it, everything changed. But that's a story for a later chapter. For now, just know this. You live in a world built on 0. Your phone, your computer, your calendar, your bank account, your calculator, they all rely on that tiny circle. That strange, quiet, invisible symbol of absence, of nothingness. And the best part? It's just the beginning. So as you lay back and close your eyes, remember, the number 0 may look like nothing, but it might just be the most powerful idea humans have ever invented. And tonight, you're going to fall asleep thinking about it, or trying to. And honestly, either is perfectly fine. Let's imagine something together. It's nighttime. You're a shepherd, 4,000 years ago, somewhere in ancient Mesopotamia. The stars are out. The fire is low. The sheep are hopefully still there. You count them one by one, just like you always do. 1, 2, 3. Wait, did I count that one already? Let's start again. 1, 2. No calculators. No clocks. No notepads. Just fingers, maybe some stones, and a general sense of that looks like about 7. This is what counting was like before numbers had rules. Before we had symbols, before we had 0. Now picture this. One night, one of your sheep goes missing.
Not great.
How do you represent that? You can't write 0 sheep. 0 doesn't exist yet. You just kind of stare at the space where the sheep should be and say, well, it's not there. That's how early humans lived. Not just with sheep, but with numbers in general. They counted what was there. They didn't yet have a way to describe what wasn't. And the funny thing is, it kind of worked. People got by. They had systems, creative, strange, wildly impractical systems, but systems nonetheless. Let's start with the Sumerians. Smart folks. Invented cuneiform, the first writing system. Built cities, traded goods, told stories about gods throwing tantrums. They also had a number system based on 60. Not 10, not 5, 60. Why? No one's really sure. Maybe because 60 is divisible by lots of numbers. Maybe because someone tripped while carving and just went with it. Anyway, their system had place value. Kind of like ours. The position of a number changed its meaning. But here's the catch. They didn't have a clear symbol for 0. So if you saw something like 2, 1, you had to guess. Is that 2 and 1? 21? 201? Good luck with that. Imagine trying to read a book where sometimes the spaces between the words are invisible. That was ancient math, without 0. Later, the Babylonians came along and improved things a bit. They actually used a sort of placeholder. It wasn't a real 0, more like a double wedge mark that said, hey, something should be here, but it's not. Kind of like a passive-aggressive post-it note from a roommate. Still, they didn't treat it as a number. It wasn't something you could add, subtract, or think deeply about. It was just there to stop things from getting confusing. Which, honestly, fair enough. Meanwhile, in Egypt, math was also evolving. The Egyptians used hieroglyphs to write numbers. 1 for 1, another for 10, another for 100, and so on. But again, no 0. If you had 5 apples, great. If you had no apples, you just didn't write anything. You simply didn't mention the apples. They were erased from the narrative, like a cancelled TV character. Now here's where it gets interesting. Even though these cultures didn't have zero, they still did some pretty advanced math. They built pyramids, they navigated rivers, they tracked stars, they measured land, and they did all this while actively avoiding the concept of nothing. It's like cooking a perfect lasagna without using cheese or pasta. Is it possible? Sure. But why? So what did these early civilizations do when they needed to represent absence? They improvised. Sometimes they left a blank space. Sometimes they used a symbol that meant none, but only in a grammatical sense, not mathematically. Sometimes they just looked at the person next to them and said, "You know what I mean, right? Now here's something fun." Let's say you're a merchant in the market, selling dates. You give someone 2 baskets of dates, but they only give you 1 sheep. You're mad. You say, "This is unfair. I gave you more." They respond, "More than what?" You say, "More than 0? Except you can't say 0 because no one knows what that is. So instead you say, "I gave you 2 and you gave me 1. That's not the same." And boom, you've accidentally invented subtraction. Sort of. These kinds of real-world problems were pushing people closer and closer to realizing they needed a better system. Because at some point, just not writing anything stops working. You need to track debts. You need to record inventory. You need to tell the difference between 10 baskets and 1 basket with bad handwriting. And that's when the real genius started to show up. People who didn't just count what was, but began to wonder about what wasn't. But we're not there yet. We're still in the early days, the pre-zero world. A world where math was clunky, weird, creative, and deeply personal. There were no standard symbols, no consistent rules. Math varied from town to town, trade to trade, and let's be honest, it was a mess. But it worked, somehow, because people are persistent. They'll draw dots in the sand. They'll carve marks into bones. They'll use strings, knots, shells, beads, anything to represent meaning. Even if it's just to say, "I used to have more goats than this." So tonight, as you drift off to sleep, imagine you're back in that world, sitting by the fire, counting your sheep, noticing that one's missing. Not sure how to say it, just staring at the empty space in the herd and feeling slightly annoyed. And somewhere far in the future, someone will give that space a name. They'll call it 0. But for now, just close your eyes. You've done enough counting for one day. So, let's talk about nothing, which is awkward. Because nothing is, well, nothing. And trying to describe nothing always ends up sounding like a riddle, written by a philosopher who didn't sleep enough. But that never stopped humans from trying. You see, long before anyone invented 0, people had already started to feel uneasy about the concept of nothing. Not just in math, but in life, in the universe, in their souls. And honestly, fair enough. Nothing is weird. It's invisible. It's quiet. It doesn't take up space. And yet, somehow, it can mess everything up. Imagine this. You're a philosopher in ancient Greece. You've got a nice robe, a garden, and a lot of time on your hands. You start asking questions like, what happens after we die? Why does fire go up? And eventually, wait, what is nothing? Cue existential crisis. Now here's where it gets fun. The ancient Greeks, the same people who gave us geometry, democracy and very dramatic plays, were not fans of nothing. Especially one guy, Aristotle. Aristotle was a big deal. He wrote about physics, biology, ethics, logic, and also why nothing couldn't exist. He thought the universe hated a vacuum. Literally. He said nature abhors a vacuum, meaning if there's empty space, nature will rush to fill it. So in his mind, nothingness was unnatural.
Dangerous.
Unreal. This was more than just a science opinion. It shaped how people thought for centuries. If Aristotle said nothing couldn't exist, well then, no need to invent 0, right? You can't have a symbol for something that doesn't exist. Now jump ahead to the Roman Empire. the Romans loved order. Roads, laws, military discipline, spreadsheets. Okay, maybe not spreadsheets, but they would have loved them, and yet their number system had no zero. Not because they didn't know how, because they just didn't want it. They used Roman numerals. I, V, X, L, C, D, M.
No zero.
No placeholder, just letters, stacked in weird ways, and a whole lot of guesswork. If a Roman wanted to say nothing, they'd just say the Latin word nulla, but there was no symbol for it. No way to write 0 soldiers or 0 coins or 0 cats, which honestly explains a lot about Roman accounting. And here's the awkward part. The more civilizations tried to avoid nothing, the more they bumped into it, like a person trying to avoid stepping on a rake, but stepping on 5 rakes instead. Merchants needed to write down debts. Builders needed to measure empty space. Astronomers needed to calculate the motion of things that weren't even visible yet. But they kept running into the same problem. The world wasn't always full. Sometimes things were missing. Sometimes there was an absence, and they had no way to write that down. Now here's where things get a little spooky. In many ancient cultures, nothingness wasn't just awkward, it was scary. To some people, it symbolized death, or chaos, or the void before creation. In other words, 0 wasn't just mathematically confusing, it was spiritually unsettling. If you believed the universe was created by a god, or gods, or some eternal force, then what came before creation?
Was there nothing?
That's a terrifying idea, because if nothing can exist, then maybe everything can stop existing too. And humans don't like that. So instead of exploring the concept, a lot of people just avoided it. They filled every corner of their philosophy with something, even the empty parts. Like, this part of the universe, oh, that's filled with ether, or fire, or divine breath, or cosmic pudding. Something. Just not nothing. Because nothing would mean the universe had edges, limits, silence. And the ancient world wasn't ready for that. Now, from a modern perspective, it seems strange. We are surrounded by zeros. Bank accounts, phone numbers, clocks, passwords, binary code. We use 0 without thinking about it. But back then, 0 was radical. Too radical. And so, even as math grew more complex with triangles, circles, ratios, even early algebra, people still refused to say, you know what's missing? A number for when there's nothing. Instead, they twisted and stretched their systems around the problem, kind of like building a house and refusing to admit you need a door. Now, let's be fair. This wasn't because people were dumb. They were very smart, but their worldview was different. To them, numbers described reality. They described quantity, and if something wasn't there, it didn't need a number. End of story. It's a bit like counting cookies. If you have 5 cookies, great. If you have 2 cookies, still pretty good. If you have no cookies, well, now you're just sad. You're not thinking about math, you're thinking about betrayal. And yet, somewhere deep in the brain, a spark is forming. Because when we notice that something is missing, when we feel the absence of what used to be there, we're doing something surprisingly advanced. We're recognizing a pattern with a gap. That's the first step toward inventing 0. Not just seeing what's in front of us, but seeing what isn't. That's the awkwardness of nothing. It sits quietly, right at the edge of understanding, waiting for someone to ask the weird question. To say, what if nothing is something? And that question will eventually lead to one of the biggest revolutions in the history of math. But not yet. For now, we're still in the dark. Still fumbling through a world full of numbers, but missing the one that matters most. So as you drift off tonight, think about how strange it is that the simplest number took the longest to invent, and how something so empty can be so full of meaning. Let's take a deep breath. In, out. Now picture this. You're in ancient Rome. There are marble columns, sandals with too many straps, and everyone's yelling in Latin. You just bought some olives, maybe a few grapes, and now you need to do some math. Except, surprise, you live in a world without zero. And yes, it's as chaotic as it sounds. The Romans were brilliant in many ways. They built roads, aqueducts, law codes and stadiums that still stand today. But when it came to numbers, well, they made some choices. Let's look at Roman numerals. They go like this. I is 1, V is 5, X is 10, L is 50, C is 100, and D is 500, and M is 1,000. It's fine at first. I3, nice and simple. Then things get weird. 4 isn't I30, it's Ivar, because apparently we're subtracting now. 6 is Vi, additive again. Then 9 is Ix, and so on. Okay, confusing but manageable. Until you try to do actual math. Let's say you want to multiply xx7 by 3. That's 27 times. Good luck. There's no place value, no columns, no grid, just a string of letters and a headache. Even subtraction gets wild. What's Lx minus? Don't worry, I'll wait. Forever. Now here's the key issue. There's no zero.
None.
Nowhere. Not even a symbol for nothing in their numeral system. Which means no placeholders. No easy way to say there's nothing in this column, but keep counting. Just vibes and educated guesses. And this made Roman bookkeeping messy. Imagine you're a Roman accountant. You've got scrolls full of transactions. Someone owes you 40 coins. You write XL. Then they pay back 40 coins. Now they owe you what? Technically, nothing. But how do you write nothing in Roman numerals? You don't. You just erase the number, or leave a blank space. Or maybe you draw a sad face next to the debt and move on with your life. That's how the Romans handled it. And it worked, kind of, for a while. But as the empire got bigger, and the economy more complex, and taxes more annoying, the cracks started to show. You couldn't easily do calculations. You couldn't represent negative balances. You couldn't handle fractions or decimals or big equations. Math was more art than science, a delicate dance of scrolls, scribes, and sweaty guesswork. Now, to be fair, the Romans weren't math-obsessed like the Greeks or Egyptians. They were engineers, administrators, conquerors. They wanted bridges, not algebra. Still, the fact that they avoided zero is fascinating, because by the time Rome was at its peak, other civilizations were already playing with the concept. In India, thinkers were starting to explore zero as both a placeholder and a real number. In Babylon, people used marks to indicate missing digits. But in Rome, nope, they just kept marching. And the result? A massive empire powered by math that didn't include nothing. Which brings us to a strange truth. Sometimes progress isn't about what you add. It's about what you're willing to accept. And the Romans just weren't ready to accept nothing. They didn't see the value in absence. They didn't recognize the power of empty space. And so, they built a whole civilization on numbers that refused to be honest. Let's take another example. Imagine you're measuring land. You've got a field. It's 20 units long and 30 units wide. But one corner of it has nothing, no crops, no soil, just rocks. How do you write that into your measurements? With Roman numerals, you don't. You just skip it. I hope no one notices. And that's the awkwardness we talked about earlier. Not being able to write zero means pretending gaps don't exist. Pretending a missing part isn't missing. And that gets you into trouble. In math, in construction, in philosophy. Now here's something even better. Try writing the number 1001 in Roman numerals. It's MI. That's it. Or technically MI. But with no zero, there's no way to signal that little placeholder between the two ones. No zero to hold space in the middle. So my could be 101, or 1, or maybe my name is Marcus and I'm just making this up. You see the problem. Zero isn't just a number. its structure, its meaning. It tells you where other numbers are supposed to go. Without it, math is just a soup. Which brings us back to the Romans. Brilliant people. Terrible numerals. And yet, their system lasted for centuries. Why? Because it was familiar. Because it worked well enough. Because change is hard. Even when it makes everything better. And honestly, that's kind of beautiful. Because it shows how much patience it takes for a revolutionary idea like zero to find its place. The world didn't reject zero because it was wrong. It rejected it because it was too new, too weird, too empty. But eventually, someone looked at that emptiness and saw possibility. And that someone wasn't Roman. It was a man far from Europe, in a land where math wasn't just practical, it was poetry. But that's a story for next time. So for now, close your eyes. Imagine a world built by numbers that refuse to believe in nothing. Imagine trying to do your taxes with Roman numerals. And smile, because we don't live in that world anymore. Think zero. Let's go back, way back, not to Rome, not to Greece. Even further, we're heading to ancient Mesopotamia, around 4,000 years ago, in the land between the Tigris and Euphrates rivers. This is where people first began whispering about zero. They didn't call it that. They didn't even fully understand it. But something was beginning to take shape. This is the story of a placeholder. Now, let's set the scene. It's dusty. It's hot. You're wearing sandals made of goat. You live in a city made of mud bricks and mathematics. Because you, my friend, are a Babylonian scribe. Your job? Keeping track of numbers. Wheat, cattle, beer, bricks, taxes, more beer. You write with a stylus on a clay tablet, and your numbers look like little wedges. Because this is cuneiform, the world's first writing system. The Babylonians had a number system based on 6, not 10, like we use. Not 5, not 20. 60, high, 60. Well, we're not totally sure, but it turns out 60 is a very friendly number. You can divide it by 2, 3, 4, 5, 6. It's basically the social butterfly of numbers, and that's why we still use it today. 60 seconds in a minute, 60 minutes in an hour. Because some Babylonian said, yeah, that feels about right. Now, here's where things get interesting. Let's say you want to write the number 1. Simple, 1 wedge. Done. But what about... That's where things get weird. Because they used the same symbol, just in a different position. So 1 in the first place meant 1. 1 in the second place meant 6. 1 in the third place? That's 3. They were using place value, just like we do today, which is honestly amazing. But here's the problem. What if you want to write... That's 1 in the second place and 1 in the first. Easy enough. But what if you want to write... That's 1 in the third place and 1 in the first. Uh-oh. Where's the middle number? Where's the 0 to say, hey, nothing goes here? Exactly. There wasn't one, which led to a lot of confusion. Is it 61 or just someone carving on clay after too much fermented date juice? Eventually, the Babylonians came up with a clever trick. They invented a little double wedge symbol to act as a placeholder. It wasn't a real 0. It didn't mean nothing. It just meant there should be something here, but there isn't. Basically, I didn't forget. This space is on purpose, and honestly that's kind of genius. Because they were the first people, as far as we know, to say, you know what, we need a symbol for absence. Not to do math with, just to hold the space. It was quiet, subtle, just a whisper, but it mattered. That little placeholder was the first step towards 0, the proto-0, the beta version of nothing, and that changed everything. Suddenly, numbers made more sense. You could distinguish 61 from... You could write numbers down with clarity. You could track data better. You could make fewer mistakes when selling donkeys. But remember, this wasn't 0 as a number. They didn't treat it like something you could add or subtract. You couldn't divide by it. You couldn't say 3 minus 3 equals placeholder. It was more like punctuation, a silent character that helped you read the sentence correctly. Still, it was huge, because it showed that people were starting to understand a powerful idea, that sometimes, in order to express something, you need to represent nothing. Now, we don't know who came up with it. Some anonymous scribe, someone with a stylus, a tablet, and too many confusing numbers. But whoever they were, thank you, because they cracked open a door. They didn't walk through it. That would come centuries later. But they pushed it open just a little, just enough to let the idea escape. The idea that absence can be written, that silence can be part of the message, that nothing is worth mentioning. Think about how big that is. Most inventions are about adding things. The wheel, the plough, the sandwich. But this was about removing something, about leaving a space, and trusting that the space itself had meaning. That's not just math, that's art. Now, it would still take many, many years for zero to become what it is today. It had to travel across cultures. It had to meet philosophy, religion, and resistance. But here, in Babylon, it started as a whisper. Just a mark, just a gap, and somehow, that was enough. So as you lie back and drift off, imagine that scribe, carving careful marks into a slab of clay, counting jars of grain, pausing for a moment, and thinking, there's nothing here. And instead of ignoring it, they decided to write it down. Not because they knew what it meant, but because they knew it meant something. Even if it was just nothing. Let's travel again. We're leaving Babylon behind. We're heading east, to ancient India. The year is somewhere around 600. The monsoon rains are falling. People are trading spices, reciting poetry, meditating under banyan trees. And someone is about to invent nothing. But not the empty kind of nothing.
Not that I forgot my homework kind.
Not the my love life kind. This is real, mathematical, structured, useful nothing. This is zero, finally stepping into the spotlight. Now let's meet the star of our story. Brahmagupta. Cool name, right? He was a mathematician and astronomer who lived in Rajasthan, in western India. He wore robes, read the stars, and casually wrote one of the most influential math books in human history. The title of this book, the Brahmasfuta Siddhanta, which, loosely translated, means the opening of the universe, or possibly, how to confuse future math students with a cool name. But don't worry, the book itself was a masterpiece, and in its pages, Brahmagupta did something no one had done before. He defined zero, not as a placeholder, not as a gap, not as a shrug, but as a number, a real, usable, calculable number. He said, zero is the result of subtracting a number from itself, like 3 minus 3 equals 0. Boom. Nothing. But something. He gave rules for how zero works. Add 0 to anything. You still have the same thing. 5. Easy. Subtract 0. Still the same. 7. Nice. But here's where it gets spicy. He also said, a number minus itself equals 0. Like 12, which seems obvious now. But at the time, this was revolutionary. Why? Because this meant you could do operations with 0. It wasn't just a space holder. It was a participant. It had mathematical agency. Brahmagupta even tried division. He said, 0 divided by any number is 0. Correct. But what about dividing by 0? That one tripped him up a little. He wrote that 0 divided by 0 is 0, which, to be fair, sounds reasonable. But turns out, it's not. Don't worry, we'll get to that whole mess in a later chapter. The important thing here is, he tried. He saw 0 not as a symbol, but as a concept, as something that deserved rules, logic, respect. Now let's talk about the culture that allowed this to happen. Ancient Indian thought was deeply philosophical. People thought a lot about nothingness, not in a panicked way, in a curious, meditative way. In Hindu and Buddhist traditions, the idea of emptiness wasn't scary. It was peaceful, sacred, balanced. Where other civilizations feared the void, Indian thinkers embraced it. They asked questions like, what happens when something disappears? Can emptiness be a state of being? What if nothing is just the space where something could be? This mindset helped make zero possible. Because in India, nothing wasn't taboo. It was interesting, and that meant mathematicians could explore it without being told. Hey, stop trying to break the universe. Now here's a fun bit. Brahmagupta liked to use real-world examples to explain math. He once described subtraction using cows. Let's say you have 10 cows. Then you lose 10 cows. You now have 0 cows. A tragedy. Yes, but also a beautiful math problem. He explained how you could subtract bigger numbers from smaller ones too, which meant negative numbers. Yep, Brahmagupta was also one of the first people to play with the idea of numbers below 0. So if you had 5 cows and lost 10, you'd now have negative 5 cows, which probably means you owe someone cows. Or you've entered some sort of cow-based debt spiral. Either way, math just got more powerful, because once you accept 0, you open the door to a whole new side of the number line. The upside down part, the debts, the temperatures below freezing, the emotions after reading YouTube comments. Now, at this point, 0 was still written as a dot. Just a little dot, like a tiny pebble sitting politely between numbers. But that dot would eventually evolve. It would become the 0 we know today, a nice clean circle. And it all started here, in India, with Brahmagupta, and probably some very confused cows. Of course, not everyone embraced it right away. Even within India, the idea of 0 took time to spread. But the seed was planted, the math was written, the rules were set, and from here, 0 would begin its long journey westward. It would travel along the Silk Road, through the Islamic world into Europe, and eventually into everything. But before we go global, let's just pause, because this is a big moment. This is the first time in history where nothing was given a number, a name, a job. It wasn't just the absence of something, it was its own thing, a quiet revolution, written on palm leaves, shared by monks and scholars and curious minds. So as you lay back tonight, just think, somewhere, 14 centuries ago, a man in robes sat under a tree, looked at an empty field of cows, and decided that the absence of cows deserved its own symbol. And from that simple decision, our entire modern world was born. That's the power of nothing. Let's slow down, even more than usual. Let's breathe in and out and sink gently into the idea of nothing. Not as a number, not as a problem to solve, but as a concept. Tonight, we're going to sit in the emptiness, because to really understand 0, the 0 that broke reality and fixed it again, you have to leave the math classroom for a minute and step into a temple, somewhere far away, somewhere silent, where a monk is sitting under a tree, doing absolutely nothing. But is it really nothing? Or is it something else? You see, long before 0 was accepted in the West, long before calculators, taxes, decimals, and donuts, people in the East were already thinking about the void. In India, in China, in Japan, in the writings of mystics, monks, and philosophers, nothingness was not feared, it was explored. Let's start with a simple question. What is a void? Is it a space with nothing in it? Or is it the space where something could be? Is a blank canvas empty? Or is it full of possibilities? That's what a lot of ancient thinkers were asking, especially in Buddhist and Hindu philosophy, where the concept of shunyata, the void or emptiness, was central. Now, shunyata doesn't mean nothing in a depressing way. It doesn't mean meaningless or pointless. It means emptiness of a fixed self.
A recognition that things are always changing.
That form is temporary. That identity is flexible. That everything is connected through space. And this had an influence on mathematics. believe it or not, because once you're comfortable thinking about emptiness, you can start assigning it structure. You can say, this isn't just blank, it's part of the system. This silence is not a mistake, it's a note in the song. This nothing matters. That's the philosophy behind zero, and it shows up in more places than you might think. Take Taoism, for example, an ancient Chinese philosophy that loves paradox, that says things like, to fill a cup, you must first empty it, or the usefulness of a pot lies in its emptiness. In other words, the space inside the bowl is what makes it useful. The non-thing is the important thing, and this echoes something you've probably never noticed. A zero is a circle, a space enclosed by something. It's not just a hole, it's a hole with boundaries. It's defined emptiness. Now here's something even more relaxing. Zen Buddhism. Zen masters have a whole tradition of saying things that make your brain melt. Like, what is the sound of one hand clapping? Or, if you meet the Buddha on the road, kill him. Don't take that one literally, but behind the strange phrases is a deep, calming truth. Reality is not always logical. Sometimes, understanding comes from letting go, not solving, not calculating, just being. And you know what? That's kind of what zero teaches us too, because zero isn't the result of a calculation. It's the space that allows calculations to happen. It's not a prize, it's a foundation. It's not flashy, but without it, the entire structure of math collapses. Here's a fun example. Imagine a page full of numbers. Huge numbers, wild equations, loops and charts and graphs. Now, take away all the zeros. Suddenly, it's unreadable. Nothing makes sense. There's no alignment, no balance. It's chaos. Zero doesn't do much, but it holds everything together. And that's the zen of it. Sometimes the most powerful things are the ones that sit quietly, do nothing, say nothing, but allow everything. Now, let's get even sleepier. In Japanese calligraphy there's a symbol called enso, a hand-drawn circle, made in one breath, usually with black ink on white paper. It's often left incomplete, open at one side, a little gap, a little imperfection. But that imperfection is intentional, because it symbolizes wholeness and emptiness at the same time. Sound familiar? It should, because that's zero. That's the math symbol that looks like enso, a circle, a space, complete and empty. So here's a wild thought. Maybe zero isn't just a number. Maybe it's a symbol of something deeper. Something about letting go. Something about accepting emptiness as part of the system. Not a mistake, but a design. And maybe that's why it took so long for zero to catch on in the West. Because it wasn't just a technical problem. It was a philosophical one. People had to stop fearing emptiness, stop fighting it, and start understanding it. Only then could they say, okay, fine, we'll write it down. So tonight, as you drift off, let your thoughts be like a blank page. Let the silence be a friend. And if your brain offers you a math problem, just let it float away. Because sometimes nothing is exactly what you need, especially when it's shaped like a circle. So far we've met zero as an idea, a dot in India, a whisper in Babylon, a terrifying concept to Roman accountants. But now, zero goes on an adventure. Not a dramatic, sword-waving kind of journey. More like a scroll in a saddlebag kind of journey. Quiet, slow, determined, just like zero itself. This chapter is all about how zero left home and began to conquer the world. Our story begins with the Silk Road. Not an actual road, really. More like a messy, winding web of trade routes stretching from China to the Mediterranean. A spaghetti of camels, caravans, and slightly suspicious merchants. People traded silk, spices, gems, horses, and occasionally, ideas. And one of the most powerful ideas to travel that path was zero. You see, Indian scholars had been developing some very useful math. They had numbers. They had rules. They had zero. And those ideas didn't just stay in India. They travelled west, through Persia, through the Islamic world, and eventually into Europe. But first, they passed through Baghdad. Now, if you're picturing camels and tents, hit pause, because 8th century Baghdad was basically the intellectual capital of the world. It had libraries, observatories, philosophers and translators, and more scrolls than you could count, unless you were really good at math. The most famous place of all, the House of Wisdom. That was its actual name. And it was full of scholars translating Greek, Indian, and Persian texts into Arabic. It was like an ancient Wikipedia, but everyone had a beard. And here, in this magical melting pot of knowledge, Zero found a new home. Arabic mathematicians took the Indian system, including the zero, and said, okay, this is really good. Let's work with it. One of the most important figures, Al-Khwarizmi, he was a Persian mathematician who wrote a book on calculation using Hindu numerals, which included, you guessed it, zero. His name, by the way, is where we get the word algorithm. So next time your phone autocorrects a text into complete nonsense, you can thank Al-Khwarizmi. Anyway, he helped spread the use of zero throughout the Islamic world. And from there, it kept going. It crossed deserts. It boarded ships. It travelled in the margins of letters, the footnotes of philosophy, the scribbles of merchants. It wasn't loud. It didn't announce itself. It just showed up. Now, not everyone welcomed it with open arms. Some people thought it was suspicious, too abstract, too foreign, because zero didn't just come with numbers. It came with a new way of thinking. A way that was elegant, efficient, dangerously powerful. The Hindu-Arabic numeral system, the one we still use today, blew the Roman system out of the water. Instead of M's and X's and L's and V's, you got nice, neat digits, with place value, and most importantly, with zero. Now let's take a moment to appreciate what this system actually made possible. Try multiplying 1023 by 57 in Roman numerals. Go ahead, wait, don't. You'll never fall asleep. But now try it in Hindu-Arabic numerals on a 1023. Still annoying, but doable. Thanks, Zero. That's what made this system so revolutionary. It wasn't just prettier, it was functional. You could write big numbers easily. You could do long division without crying. You could represent absence with precision. And so, slowly, this new system, this zero-included system, moved westward. Eventually, it reached Europe. And you'd think people would be excited, right? Wrong. Europe was still deep in the Middle Ages. Most people couldn't read, and the idea of numbers coming from the east made some folks nervous. There were suspicions, whispers, laws banning the use of Arabic numerals in certain cities. Yes, people literally banned zero. In places like Florence in the 13th century, you could get in trouble for using those weird foreign digits. People thought you could cheat with zero. Like if someone owed you 10 coins, maybe they'd sneak a zero in and turn it into 100. Can't do that with Roman numerals. So zero became this strange, slightly shady character. Too useful to ignore. Too foreign to trust. But that didn't stop it, because zero had logic on its side, and logic always wins. Eventually, over time, merchants started using it anyway, quietly, in ledgers, in margins, anywhere they needed math that actually worked. And from there, it spread. It crept into universities, into scientific texts, into astronomy, into architecture. And once Fibonacci got involved, it was game over. But we'll get to him soon. For now, let's pause. Because this little number, this zero, has now officially gone global. From the temples of India, to the deserts of Arabia, to the markets of Venice, all without saying a word, just being what it always was, a quiet, round, perfect circle of possibility. So, as you close your eyes tonight, imagine that journey. Not a hero's journey. Not a war, just an idea, passed from hand to hand, from teacher to student, from east to west, like a candle flame, lighting the dark, The zero didn't force its way into the world. It was carried by thinkers, by dreamers, by people who believed that even nothing deserves to be counted. Let's set the scene. It's the Middle Ages. You're in Europe. The streets are muddy. The soup is questionable. Someone nearby is yelling in Latin, probably about morality. And math? Well, math is in a weird place. Because guess what? Just arrived. Zero. Quiet. Round. Suspicious zero. Fresh off its journey from India. Through the Islamic world and into the hands of some very confused Europeans. And the reaction? Panic. Mild, polite panic. Followed by suspicion, fear, and in some places, actual bans. You see, to us, zero feels like an old friend. It sits at the end of numbers. It balances equations. It lets us know how broke we are. But to medieval Europe it was terrifying. Because zero was foreign. It came with strange symbols. It belonged to a system invented by people outside the Christian world. And worse, it didn't make any sense. Let's start with the practical issue. Most Europeans were still using Roman numerals. Mem, D, C, L, X. A system that, as you now know, was deeply committed to not including zero. So when merchants and mathematicians started using this newfangled Hindu, Arabic numeral system, with its curvy digits and unsettling efficiency, traditionalists were not amused. They said things like, why use a zero when you could just leave a space? Or, this is too easy, it must be cheating. Or, occasionally, this is the work of the devil. And yes, that happened. In 1299, the city of Florence actually banned the use of Arabic numerals, not because they were mathematically incorrect, but because people feared they were easier to forge. A clever merchant could turn a 1 into a 7, or sneak in an extra 0 to inflate an amount. It felt shady. And in a time when math and morality were dangerously close together, using foreign symbols wasn't just suspicious. It was possibly heretical. Because here's the deeper issue. Zero didn't just come with a new way of calculating. It came with a new way of thinking. A way that included absence. That accepted nothingness as a building block. That allowed negative numbers, debt, and infinity. In a society built around absolute right and wrong, heaven and hell, good and evil, the idea that nothing could be treated like something was deeply uncomfortable. Some theologians argued, if God created everything, how can there be nothing? Doesn't that imply a flaw in creation? Others thought zero opened the door to dangerous questions, like what existed before the world? What lies outside the universe? Can a soul be worth zero? You can see why this little number was causing such a stir. Now let's add some drama. Imagine you're a young merchant in 1300s Venice. You've just started using Arabic numerals in your ledger. You like them. They make things simpler, cleaner, more accurate. Then one day, a city official knocks on your door and says, "We've heard you've been doing math differently." And just like that, your account book is suspicious. Your numbers are dangerous. Your zeros are evidence. And yet, people kept using them because they worked. Slowly but surely, zero spread. Not through sermons or public acceptance, but through practicality. Bankers realized it made interest calculations easier. Merchants realized it helped with inventories. Astronomers realized it let them write equations that actually matched the stars. In secret, people started switching over. They still taught Roman numerals in schools, but used Hindu Arabic numerals in business. Classic medieval move. Now, of course, not everyone was afraid. There were some brave souls who saw the beauty in this new math. And one of them would become very important in our next chapter, but we're not there yet. For now, Europe is still clinging to the old ways. Still suspicious of the circle, still uncomfortable with the void, and you know what? That's understandable. Because zero was never just a number. It was a symbol of change, of uncertainty, of the idea that absence could be structured. that the space between things could be as meaningful as the things themselves, and in a world obsessed with structure, hierarchy and order, that kind of thinking was revolutionary. So tonight, as you drift off, picture a dusty medieval marketplace. Cobblestones, candles, cold soup, and somewhere in the corner, a merchant adding a quiet little zero to the end of a number. Not because it's safe, not because it's accepted, but because it makes sense. And slowly, quietly, that's how reality begins to shift. Let's dim the candles, pull the robe a little tighter, and walk softly into one of the strangest chapters in mathematical history. The part where zero goes to church. You see, back in medieval Europe, the church wasn't just a religious institution. It was the center of everything. It ran schools, wrote laws, crowned kings, and approved basically all knowledge. And that included math. So when zero arrived, this mysterious number from distant lands, the church had some questions. Because zero didn't just mess with arithmetic, it messed with theology. Let's start with the big one. If God created everything, how can nothing exist? You can't say God made nothing, because that's a contradiction. And if something exists outside of what God created, well, that's even worse. So to suggest that zero, a literal symbol of absence, had a place in the system, that was not a small thing. It was a metaphysical crisis, wrapped in a tiny circle. And the church didn't love that. It's not that they held public trials for zero. No one was burned at the stake for saying 0 divided by 3. Though if you said 3 divided by 0, they might have at least raised an eyebrow. It was more subtle. The 0 wasn't trusted because it seemed to defy creation. It looked like a loophole, a shadow at the edge of God's orderly, structured universe. And then there was the issue of infinity. Because once you accept 0, you also start to think about the opposite. About endlessness. About the number line stretching out forever in both directions. And suddenly, math becomes a playground for eternal questions. What happens if you divide 1 by 0? What happens if you multiply 0 by infinity? Is 0 just the tip of a void that leads nowhere, or everywhere? You can see how this might make a few bishops nervous. Now, to be fair, not all church thinkers rejected math. Far from it. Many monks were incredible scholars. They copied ancient texts, preserved knowledge, calculated lunar calendars, predicted eclipses, all good, clean monastic fun. But 0 still carried a kind of foreign energy. It came from India, through Islamic lands, into Europe, wrapped in Arabic script and strange new rules. It wasn't just a new number, it was a new way of knowing, and that made it harder to absorb into the official worldview. Let's take a look at one example. Division. Try explaining this to a medieval scholar. You can divide 6 by 3. That's divide 6 by 2. That's divide 6 by 1. That's 6. Divide 6 by 0. And suddenly your universe explodes. Why? Because dividing by 0 is undefined. It doesn't make sense. It breaks the rules. It creates a contradiction. 6 divided by 0 would mean, what number times 0 equals 6? And the answer is, no number. Nothing multiplied by 0 gives you 6, or 5, or 1, or anything other than 0. So the operation collapses. You fall into the abyss. And theologians didn't love the idea of falling into anything called the abyss. It just had a certain hellish ring to it. So instead of embracing the weirdness of 0, many scholars tried to avoid it. They stuck to Roman numerals. They worked around problems. They politely ignored the elephant in the math room. But not forever, because as more thinkers began to explore the mysteries of the natural world, they realized that nothingness couldn't be ignored. In physics, you need 0 to talk about motion and rest. In geometry, you need 0 to describe points, lines, and limits. In astronomy, you need 0 to calculate planetary alignments and eclipses. And so, very slowly, the church began to loosen its grip. Not because it fell in love with zero, but because the world demanded it. Nature was too complex. The stars were too precise. The systems of the universe needed a number that could sit silently at the center, holding space. That number was zero. It was sneaky. It was subtle. It didn't shout or wave flags. It just made everything work better. And eventually, even theology found a way to live with it. Some thinkers began to reinterpret the void, not as absence, but as potential. Not as chaos, but as the space where divine order begins. And that's kind of beautiful, because it means that even the church, the most structure-loving institution in Europe, found a way to make peace with nothing. So as you settle in and drift off tonight, imagine a grand stone cathedral full of candlelight, long robes, heavy books, quiet arguments, and somewhere in the corner of a dusty manuscript, a tiny zero, written carefully by a monk with ink-stained fingers, a symbol of silence, of space, of the idea that sometimes what isn't there can be just as important as what is. Let's set the scene. It's the year... You're in Pisa. Not the touristy Pisa with the souvenir magnets. The medieval Pisa. All boats, markets and shouting. And into this picture steps a man named Leonardo of Pisa. You might know him better by his nickname, Fibonacci. Yes, that Fibonacci. The one with the spiral. The one whose sequence shows up in sunflowers, pine cones, hurricanes, and sometimes your fridge magnet collection. But before the spiral, there was the zero. And this is the part nobody tells you. Before Fibonacci was the poster boy for patterns, he was the guy who snuck zero into Europe. Wrapped in equations and camel dust, here's how it happened. Fibonacci's dad was a merchant. Smart, practical, connected. And he got a job managing trade for Pisa in Bugia, a port city in what is now Algeria. So young Leonardo grew up surrounded by Arabic mathematics. He saw traders using efficient digits. He watched scholars solving problems with strange little symbols. He saw math that worked, and one symbol caught his eye. A circle, small, silent, sitting at the end of a number like it belonged there. It was zero, and Fibonacci was hooked. He realized this wasn't just a symbol, it was a tool, a key to a better system, a way to actually do math without melting your brain. So he studied, he asked questions, he learned from Muslim scholars, read ancient Indian ideas, absorbed everything he could. And when he returned to Italy, he brought zero with him, not in a bag, not carved into a rock, but in a book. A very important book. Its title, Fibonacci, which sounds like a Harry Potter spell, but actually means the Book of Calculation. Published in 1202, this book introduced Europe to Hindu Arabic numerals. Fibonacci explained how they worked. He laid out place value, showed how to multiply and divide, convert fractions, solve word problems, even deal with interest rates and currency exchange. It was math, but finally, it made sense. And right there in the middle of it all was zero. That quiet, perfect, round placeholder, the number that meant nothing, but made everything else possible. Now, here's the best part. Fibonacci didn't try to make zero mysterious. He didn't cloak it in philosophy or religion. He just used it, like it belonged, like it was obvious. And to anyone with a working brain and a ledger to balance, it was. His book spread. Slowly, yes, but it made waves. Merchants loved it. Mathematicians admired it. Educated people began switching over. And even though the old system stuck around for a while, those clunky Roman numerals were tough to kill. The change had begun. All because one curious guy went on a math study abroad trip and came home with a better way to write numbers. Now, let's not forget the funny part. Even though Fibonacci gave us one of the most important books in mathematical history, he wasn't super famous in his own time. He didn't go viral. He didn't No one made Fibonacci plushies. But his ideas did spread. And within a few centuries, zero was everywhere. Bankers, builders, astronomers, clockmakers, everyone started to realize, if we use 0, this gets easier. It was like switching from chiseling emails into stone to just typing. And once you have 0, you unlock the rest of the number system. You get decimals, you get algebra, you get negative numbers, you get entire branches of math that wouldn't even exist without that tiny circle. But none of that would have happened, at least not so soon, without Fibonacci. Because he didn't just bring home a new symbol, he brought home a new mindset, a way of seeing numbers not as rigid rules, but as flexible tools. He didn't worship 0, he didn't fear it, he just respected what it could do, and that's why it worked. So tonight, as you drift off, picture this: a dusty port city, a curious teenager watching a merchant scribble equations in the sand, a spark of recognition, and years later, a book filled with logic, patience, and one very important nothing. Fibonacci didn't invent 0, but he gave it to the world, wrapped in explanations, disguised as common sense. And from there, everything changed. Let's start with a number. Not exciting, right? Kind of bland. Maybe sounds like an apartment number, or the price of something you wish was cheaper. But look again. That number, 203, is secretly a masterpiece. A little magic trick that only works because of one thing: place value. And place value only works because of one thing: 0. Let's break it down slowly. In our number system, the Hindi-Arabic system, digits change their meaning depending on where they're sitting. So in 2030, the 20 doesn't just mean 2, it means 200. And the 3 doesn't just mean 3, it means 3 ones. So what about the 0? Yes, the 0. It means no tens, just an empty space. A silent message that says, hey, there's nothing here, but that's on purpose. Without it, 23 becomes 20, which is a totally different number. Like 180 up. You do not want to forget your 0 when paying rent. So that little 0, it holds the space. It keeps the meaning. It tells you where you are in the number universe. It's basically math's version of a traffic cone. Nothing here, but don't crash. Now imagine a world without place value.
Actually, we already did that.
Remember the Romans? They had no place value. Each symbol had to represent its full value every time. There was no such thing as a tens place or a hundreds place. So they needed new symbols for every new amount. X is 10. C is 100. M is 1,000. It works, barely. But it's clunky. It's like trying to write a novel using only emojis.
You can do it, but why?
With place value, we can reuse the same 10 digits, 0 through 9, to write any number. That's efficiency. That's elegance. That's 0. Because 0 isn't just a digit. It's the glue that holds the structure together. Let's try another number. Now take away the zeros. You get... nope. Totally different number. The zeros aren't fluff. They're not decoration. They're essential. They tell you what every other digit is doing. They're like the stage crew in a theatre. Never in the spotlight, but making everything work. Without them, the show collapses. Now, this might feel basic, but here's the truth. This system, the one you learnt in school, probably while eating glue or doodling in your notebook, is one of the most powerful inventions in human history. It lets us do huge calculations. It allows banking, engineering, science, technology. It makes spreadsheets possible. Okay, that one's a mixed blessing, but still, it's all because of place value. And 0 is what makes place value possible. It tells us when a place is empty. It lets us line things up properly. It allows us to scale numbers without changing their meaning. Without 0. 100 is just 1 followed by confusion. 1000 is just 1 yelling really loudly. But with 0, we can represent size, order, and precision, all with just a few digits. Here's a fun thought. Our number system only has 10 digits. 0 through 9, and with just those, we can count to 1 billion, or 1 trillion, or a googolplex, all because of how the digits are arranged. That's the magic of place value. That's the magic of 0. It's the quiet agreement between every number. If you leave a space, I'll know what it means. It's like math, learning to whisper. Now let's look at decimals, because 0 has a job there too. Say you have 3. That 0, it tells you there are no tenths, only 2 hundredths. Take it out, and you get 3, which is very different. Ask any baker or rocket scientist. 0 gives decimals their accuracy. It lets us zoom in on small amounts without losing track. Whether you're measuring flour or fuel, 0's got your back. It keeps numbers in line.
Literally.
Think of a column of numbers. Was on hasn't semen. Without 0's, those digits wouldn't stack properly. You'd be guessing where the one's place is. Where the 10s go. It would be chaos. But 0 holds the line, keeps the order, makes sure every digit knows where to stand. It's like math's most underpaid stage manager. And here's the kicker. 0 does all this without having value. It doesn't add anything. It doesn't multiply anything. It's literally worth nothing. But its position, that's priceless. So tonight, as you close your eyes, think about how strange it is that the most powerful part of our number system is the one digit that means nothing, but makes everything work. 23, 1000. Without the 0's, they're just noise. With the 0's, they're structure, meaning precision. So next time someone says, it's just a 0, smile quietly, because you know the truth. It's never just a 0. Let's start with a simple question. What is x? If you just had a tiny flashback to high school math class, don't worry. This is the soft, sleepy version of algebra. No pop quizzes, no graph paper, just gentle thinking, and maybe a nap. Algebra is the part of math where things get poetic. It's all about balance, equality, finding unknowns by carefully arranging the knowns. And at the heart of all that, 0. You see, algebra works because of equations. And equations work because of one magical symbol, the equal sign, which means these two things are the same. And when they're not the same, that's where 0 comes in. Let's take an example. x5, this little equation is saying, whatever x is, if you subtract 5, you end up with nothing, 0. So to find x, we just do the opposite. We add 5 to both sides, and we find out x. Congratulations, you just did algebra, without stress, while horizontal. Now, here's the key. That 0 on the right, that's not just there to look pretty. It's what makes the equation solvable. It's the target, the balance point, the perfect center. 0 tells you when the equation is done. It's like the click in a puzzle when everything fits. Without 0, algebra doesn't really work. You'd be solving for x, say something mysterious. Instead of x, its exact value that brings the whole thing into balance. And that's what algebra is all about. Balance. You move things around, you cancel terms, you simplify, until one side equals the other, until the equation rests peacefully. At 0, let's try another one. 2. To solve, you subtract 3 from both sides. Then divide by 2. Rexy, you didn't see 0 in the final answer, but it was there. In the logic, in the step. In every moment where one thing was removed, another balanced out. 0 is the silent partner in every equation. Now let's talk about something cool. In the early days of algebra, people didn't even use symbols. They used words. Imagine writing, the thing when doubled and increased by 3 gives 11. That was an actual math problem. No equal signs, no variables, just poetic math riddles. But eventually, people got tired of writing all that, so they invented symbols. X. And, of course, and as equations became shorter, they also became more powerful, because now you could spot patterns. You could test theories. You could solve problems that used to take an hour in seconds. And at the center of it all, always was zero, because solving equations is all about getting to zero, reducing the difference, finding the balance, eliminating the noise. You take both sides of an equation and slowly cancel everything out until the only thing left is nothing, which means you've arrived. And that's kind of beautiful. Zero is the signal that your work is done, that you found a place of perfect equilibrium. It's math's version of inner peace. Now here's something fun. The word algebra comes from Arabic. It comes from the word al-jabr, which means reunion or restoration. Because algebra is about putting things back together, fixing equations, balancing the system. And guess who helps you do that every single time? Yeah, zero. Even when it doesn't show up in the final answer, it's the reason the method works. Now, let's think about equations with no solution, like x pals 3. If you subtract x from both sides, you get 3. Uh-oh, that's not true. The equation broke, because there's no value of x that can fix that. No balance, no zero. And in math, when things don't reduce to zero, that usually means something's off. So even wrong answers owe their truth to zero. Zero is how we know when a system can't work. It's not just a solution. It's also a filter, a boundary between solvable and unsolvable. It's math's final word. Now let's zoom out for a second. Algebra powers almost everything. Economics, physics, engineering, even basic decision making. And it all depends on being able to set things equal and move towards zero. So tonight, as you rest your head and drift away, picture an equation. On one side, a mystery. On the other, your tools, numbers, logic, quiet steps forward. And every time you simplify, every time you subtract, you get a little closer to balance, to truth, to nothing. Zero isn't just the end of the problem. It's the reason the problem has a solution at all. Let's start small. No, smaller. Smaller than a grain of sand. Smaller than a dust particle floating in sunlight. Smaller than the thing your cat knocked off the table just to watch it fall. We're talking infinitesimally small. Almost nothing. But not quite. Welcome to the sleepy, slippery world of calculus. Don't worry. No need to panic. There won't be any scary graphs or symbols jumping out at you. Just soft, strange stories about motion and the magic of almost zero. Now, calculus is all about change. It's how we measure things that are moving, growing, shrinking, accelerating, curling through space like sleepy spaghetti. And at the heart of it all, zero. Or rather, almost zero. Let's take an example. Say you're walking in a straight line. You take 1 step per second. Easy. Predictable. But what if you're speeding up? Now things get trickier. You're not just moving, you're changing how fast you move. And if you want to measure that, you need calculus. Specifically, you need something called a derivative. Sounds intense, but it's really just a fancy way of asking, how fast is this thing changing right now? To answer that, mathematicians realized they could take 2 points, measure the change between them, and then shrink the space between those points, smaller and smaller, closer and closer, until the difference becomes infinitely small, not zero, but so close to zero that it acts like zero. That's an infinitesimal, and that's the trick behind calculus. You zoom in so far that curves become lines. That movement becomes stillness. That change becomes a snapshot. It's like taking a video and analyzing it 1 frame at a time, until each frame is so close to the next, it feels like you've captured reality. Now you might be thinking, wait, are we allowed to do math with numbers that are almost zero? Great question. Early on, this was actually a big problem. Back in the 1600s, 2 brilliant thinkers, Isaac Newton in England and Gottfried Wilhelm Leibniz in Germany, both came up with calculus around the same time. Yes, independently. because apparently the 1600s were very boring unless you were inventing entire branches of mathematics. Newton called his version fluxions, Leibniz called his infinitesimals, and both of them used the same basic idea. Take a very tiny change, measure it, use it to figure out how things move. They didn't technically use zero, because dividing by zero is still a no-no, but they used values that approached zero. That got so close they were practically kissing it. This is what we now call a limit. A limit is what happens as a value gets closer and closer to zero without ever quite reaching it. Kind of like trying to touch a mirror. You can get closer and closer, but unless you go through the glass, you never fully arrive. And here's the beautiful part. Using limits, mathematicians could now describe motion, acceleration, growth, curves, surfaces, even the orbits of planets. All because they got really good at understanding almost nothing. And zero became the center of it all. It was the point everything moved around, the boundary, the cliff's edge. You never quite fall into it, but you get close enough to build a theory. Now, here's something cozy to think about. Calculus lets us describe instantaneous change. The exact speed of something at a single moment. Like, how fast is your heart beating right now? Or, how quickly is this candle melting at this exact second? That's the power of zero. It turns change into something you can measure. It makes the chaotic smooth, the impossible possible. And calculus isn't just theory. It's everywhere. It powers physics. It models climate. It designs bridges. It tells your phone how to scroll smoothly. It's in medicine, rocket science, animation,
Economics.
even the curve of your pillow. And none of it would work without our old friend zero. Not as a final answer, but as a destination, as a limit, as something we can get infinitely close to without falling in. Now here's a little mind twist, just before bed. In a way, zero in calculus is never quite real. It's always just out of reach. The value you approach but never arrive at. The idea that lets you model the instant, even though an instant has no length. It's like trying to catch a moment with a butterfly net. You never get the thing itself, but the shape of it is enough. So tonight, as you settle in, think about how strange it is that the fastest moving things in the universe can only be understood by getting as close as possible to standing still. That motion becomes math only when we start slicing time into pieces so small they're almost not there at all.
And at the heart of it,
Zero. Always zero. Not nothing, but everything you need to describe how the world actually moves. Okay, let's do something reckless. Let's try to divide by zero. Just for fun. Just once. What could possibly go wrong? Well, everything. Dividing by zero is the one move in math that absolutely breaks the rules. It's not illegal. It's just undefined. Which is math speak for this doesn't even make sense. But let's take it slow. Say you have 6 divided by 3. That's 2. Because 3 goes into 6 twice. Now try 6 divided by 2. Still good. That's 3. Now try 6 divided by 1. Getting bigger, it's 6. So here's a question. As the number you divide by gets smaller, what happens to the answer? Let's go smaller. 6 divided by... That's 12. 6 divided by 60. 6 divided by 60,000. See the trend? The smaller the divisor gets, the bigger the answer. You're squeezing the same amount into tinier and tinier slices, so you get more of them. Now, let's go all the way. 6 divided by 0. Boom. Broken. Not a big number. Not infinity. Just undefined. Why? Because the question doesn't even make sense anymore. Let's flip it around. When you divide 6 by 3, you're asking, what number times 3 equals 6? Answer. So now ask.
What number times 0 equals 6?
Trick question. Nothing times 0 equals 6. Because everything times 0 equals 0. You can't multiply your way from 0 to 6. It's like trying to build a skyscraper out of fog. No matter how many floors you stack, it's still just fog. So the equation has no solution. Not one. Not many.
None.
And that's why dividing by 0 is undefined. It's not a number. It's a contradiction. It tears a hole in the logic. And math doesn't like holes. Now here's where it gets juicy. Some people over the centuries tried to define it anyway. They said, what if we just call it infinity? Others said, what if it's negative infinity? Still others said, let's go get lunch instead. But no definition ever worked, because every attempt created more contradictions. Imagine this. If dividing by 0 gave you infinity, then any number divided by 0 would give the same result. So 6 and 7, which would mean, oops, now your math homework just disproved reality. Hope you're happy. This is why dividing by 0 isn't just wrong, it's dangerous. It leads to equations that destroy meaning. And in math, meaning is everything. Now, computers? They hate dividing by 0 even more than we do. Ask your calculator to do it. You'll either get an error, or a blank screen, or a very dramatic, undefined message. Sometimes it'll just crash. Poof. Gone. And in programming, dividing by 0 can cause a whole system to break down. Infinite loops, freezing screens, crashes, all because someone got a little too confident with their denominator. Now let's talk about black holes, because why not? In physics, when you divide by 0 or something that behaves like 0, you can end up with a singularity. That's a point in space where gravity becomes infinite, and time itself starts acting weird. Basically, a physical version of undefined. Scientists call it a breakdown of the laws of physics, a place where the math goes so extreme, it stops being math. Dividing by 0 is how you get theoretical infinities. And infinities are nature's way of saying, yeah, we don't know either. So what's the takeaway? You can add 0. You can subtract it. You can multiply by it. But divide? Don't even think about it. 0 draws a line in the sand. A limit. A rule that even the most advanced math must respect. It's the one boundary you can approach, but never cross. And honestly, that's kind of poetic. 0 is small. It's silent. It looks harmless, but it guards the edge of logic. It says, come as close as you like, but don't step through. It's the mathematical version of a black hole, sitting quietly at the center of every equation, watching. Now here's a soft thought to fall asleep to. Maybe the reason dividing by 0 is undefined is because 0 isn't trying to be understood. It's not there to give answers. It's there to remind us that not everything has 1. That some questions just aren't solvable. That some doors don't open. And that's okay, because even in math, mystery still matters. So as you drift off tonight, picture a chalkboard, filled with numbers, and a small circle at the center, quiet, still, untouchable. The one number that refuses to be divided. The one rule that never bends. 0, the simplest number, the strongest boundary, and the most polite way of saying, you shall not pass. Take a look around you. Okay, maybe not literally.
You're probably in bed, possibly horizontal, ideally cozy.
But imagine for a moment, your phone, your laptop, the Wi-Fi router blinking in the corner, your smart fridge, your smart watch, your slightly less smart printer, all of it. Every single digital thing. It runs on 2 numbers, 1 and 0. That's it. Binary. The language of computers. No fancy symbols. No decimals. No fractions. Just on and off. Yes or no. Something or nothing. And if you look closely, if you really zoom in, you'll see that everything digital is made of tiny little decisions. 1 and 0. A signal is there. A signal is not there. Electricity flowing through a wire? That's a... No electricity? That's a 0. A light on? A light off? A switch flipped up, a switch flipped down, millions, billions, trillions of tiny choices. And that's all your computer ever does. It just flips zeros and ones really, really fast. Let's take a simple sentence, like hello in binary. That 1011 1000. 1011. Each letter, each symbol, each number is just a pattern of zeros and ones. And when you string those patterns together, you get messages, programs, websites, photos, entire games. Or, if you're lucky, one of those emails from a Nigerian prince. But the important thing is, 0 is half of the equation, and arguably the more important half, because 0 is the default, the quiet state, the no in the yes-no system. It's what tells the computer, don't do anything here. And when you have a billion zeros carefully arranged, you get silence that's full of meaning. Now let's go deeper. At the heart of every modern computer is a tiny chip. Inside that chip are transistors, tiny switches, made from silicon, so small you could fit millions of them on the tip of a pencil. Each transistor can be either on or off, which means 1 or 0, that's it. Every website you've ever visited, every photo you've ever taken, every time you've hit snooze on your alarm, that all came down to transistors flipping from 1 to 0, and back again. Now here's where it gets fun. Early computers weren't quite as sleek. They used big, clunky vacuum tubes to represent ones and zeros. Yes, actual glowing tubes, like tiny light bulbs. Your computer used to be a piece of furniture, but the logic was the same. Turn something on. It's a turn it off. That's a on, off, yes, no, presence, absent. And as technology shrank, the language of 0 remained. Because once you understand that nothing is a valid state, you can use it to build things. You can create logic gates, circuits, memory, all using zeros and ones in various combinations. It's like building castles out of sand and silence. Here's an example. Let's say you want a program to add 2 numbers. At the lowest level, that's just a series of logic operations. If this wire has a signal, 1, and that wire doesn't, 0, do this. If both wires have signals 1 and 1, do that. If both are off, 0 and 0, do nothing. It's all just rules, written in zeros and ones. And from that, you get software, email, spreadsheets, that weird talking AI that sometimes misunderstands your voice messages. It all starts with binary, and binary only works because of 0. Now let's talk storage. When you save a file, let's say a photo of your dog wearing sunglasses, that file gets converted into, guess what? A long string of zeros and ones, millions of them. And those zeros? They represent all the parts of the image where there's nothing to change. No light, no color, just absence. Without those zeros, the file would be chaos. All dogs would look like spaghetti. All sunglasses would be upside down. And no one wants that. So 0 isn't just holding a place. It's doing real work. It compresses. It simplifies. It tells the computer where to do nothing. And sometimes, that's the most important instruction of all. Now, here's something poetic. You might think of 0 as a sign of emptiness. But in computing, it's a symbol of control. A system without 0 would do everything all at once. It would melt, explode, catch fire, probably email your boss by mistake. But with 0, with careful silence, you get precision, timing, coordination. Every digital heartbeat, from your morning alarm to a Mars rover's landing, relies on billions of zeros firing in perfect rhythm. And that's kind of beautiful, because it means that nothing has become the foundation of everything. So tonight, as you settle in, imagine your phone, your tablet, your favorite app, and imagine behind the screen a universe of switches, tiny signals blinking on and off, millions of decisions happening every second, and half of them, the quiet half, are just zeros. Not broken, not lazy, just waiting, ready to hold space, keep order, make meaning. Zero didn't just break reality, it rewired it, line by line, bit by bit, and now it runs the world, without ever saying a word. Let's imagine something. You're in a spaceship, floating above Earth. Everything is calm, silent, weightless. You look at a screen that says altitude, and in that moment, that little zero means something huge. It means you've reached the line, the edge, the place where the atmosphere ends and space begins. That zero, it's not just a number, it's a boundary. Engineers love boundaries. They live for them. And that's why, even if philosophers once feared zero, engineers, they eventually made peace with it, and then they started using it everywhere. Let's take something simple, a thermometer. Most thermometers have a zero on them, not because zero is the coldest possible temperature. That title goes to absolute zero. We'll get there eventually. But because engineers needed a reference point, a place to say, this is where the scale starts. For Celsius, zero is the freezing point of water. That's useful. It lets you say things like, it's 5 degrees today, or it's -10. Stay inside. Don't go to work. No one will blame you. Zero is how we measure change. It's the anchor in the middle of a scale. Above zero, more. Below zero, less. Zero itself, perfect neutrality. Now take altimeters, the devices pilots use to measure altitude. What do they measure from? Zero. Specifically, sea level. The moment you take off, you rise above zero. The moment you land, you return to zero. It's not just a measurement.
It's a story.
You went somewhere, and then you came back. Thanks, zero. Or consider a clock. The time between two events is measured from zero. Start a stopwatch. Boom. Time equals zero. Then it begins to tick. Zero marks the start. The moment before anything happens. The stillness before motion. Without it, we'd never know how long anything takes. How far anything travels. How fast anything moves. Engineers use zero, not just in theory, but in action. In every dial, every gauge, every system that needs a baseline. Take elevators. What floor do most elevators start on? Zero. Or ground. That's where everything else is measured from. You're not 12 floors above the mystery zone. You're 12 floors above zero. Nice. Simple. Clear. Zero is how systems make sense. Now think about balance. Scales. If you're weighing something, you always start by setting the scale to zero. Why? Because zero means there's nothing here yet. Let's see what happens when we add something. It's the point of equilibrium. The quiet before the weight. The baseline. Even in engineering math, zero pops up constantly. Want to find out when a machine is stable? Look for when the forces equal zero. Want to find the point of maximum efficiency? Set the derivative to zero.
Want to design a bridge that doesn't collapse?
Well, yeah, definitely use zero in those equations. Without it, you'd just be guessing. Now, engineers didn't always love zero. There were moments in history, especially early on, when it caused confusion, like trying to divide by zero in a formula and ending up with a number that says please stop. But over time, as systems got more precise, engineers realized that zero wasn't the enemy. It was a tool, a clean slate, a reference point, a switch that says off, a state that says M. They started using it to design better circuits, engines, feedback loops. Zero became part of the logic, a value that signaled readiness, or shutdown, or balance. Let's look at an everyday example. Your car. The fuel gauge starts at zero. The speedometer rises from zero. Your RPMs, also measured from zero. You don't need to know the entire range. You just need to know when you've moved away from nothing. Even your GPS measures from a starting point. your current location. At the beginning, your distance from the destination is, you guessed it, 0. And speaking of GPS, satellites use 0 constantly. 0 degrees latitude, 0 degrees longitude, the prime meridian, the equator, imaginary lines based on nothing, used to navigate the entire planet. That's the power of 0. In engineering, it's not absence, it's alignment. It means we're in position,
We're calibrated.
we're ready. 0 is how machines know where they are, where to begin, when to stop. Without it, nothing would sync, nothing would balance, nothing would even start. So tonight, as you drift off, think about how much in your life depends on 0. Your thermostat, your clock, your speedometer, your headphones turning off, your oven preheating, your elevator dinging, each one quietly waiting at 0 until you ask it to move. And when it returns to 0 again, it's complete. A cycle, a circuit, a full circle. The job of 0 isn't just to be empty. It's to tell you when something is exactly right. And honestly, that's more than nothing. That's everything. Let's float for a moment. No gravity, no air, no sound, just space. You're in the middle of a vacuum. No atoms, no dust, no light.
Nothing.
Or at least, that's what we used to think. Because in physics, nothing isn't as empty as it seems. In fact, nothing might be. Full of something. Welcome to one of the strangest places in science. 0 in the real world. Let's start with the basics. In physics, we often use 0 as a kind of baseline. 0 velocity means something isn't moving. 0 force means perfect balance. 0 energy, that's complicated. And then there's the holy grail of 0, absolute 0. That's the coldest possible temperature. Under 2070, or 0 on the Kelvin scale. At absolute 0, atoms stop moving, like completely. No vibration, no motion, no kinetic energy. A universe frozen in place. Except, not quite, because quantum physics says, even at absolute 0, things still wiggle. Particles pop in and out of existence. Tiny fluctuations ripple through empty space. It's called 0-point energy. It's like the universe saying, I know you asked for silence, but here's a little hum. This is where physics starts sounding like poetry. Because nothingness, real, honest nothingness, might not exist at all. The vacuum of space. Not truly empty. It's filled with fields, waves, possibilities. Even when there's no matter, there's still potential. And that's where things get weird. Let's say you try to create a perfect vacuum. No particles, no energy, no light. Physicists have tried this. They take a metal box, pump out all the air, cool it down, seal it up. It's as close to nothing as we can manage. And then they measure it and find that somehow virtual particles are still there, flickering in and out, borrowing energy, vanishing again. It's like the universe has a background buzz. You can never fully turn off. This isn't science fiction. This is quantum mechanics. The same theory that explains lasers, microchips, and radioactive decay also says that nothing is noisy. There's always something, even when there shouldn't be. Now let's talk about time. 0 plays a huge role there too. Physicists often set time 0 as the start of an event. The moment a particle decays, the instant a rocket launches, the birth of the universe. T0, time 0 is the anchor for every equation. What happened before time 0? We're not sure. Maybe nothing. Maybe something. Maybe something that looked like nothing. Cosmologists, people who study the entire universe, say that before the Big Bang, time itself may not have existed, which is confusing and kind of amazing, because it means even time has a 0 point, a place where it began. And once again, 0 is sitting right there, not doing anything, but holding the structure together. Now here's a spooky thought. Imagine you're floating in deep space. You're far from stars, planets, dust, anything. No gravity, no motion, no matter, just blackness. Would you be surrounded by nothing? Not quite, because even the vacuum of space has energy. It's low, it's thin, but it's not zero. This is called the cosmological constant, and it means the universe itself has a built-in hue, a low, quiet, eternal vibration. Some scientists believe this energy is what causes the universe to expand. Others think it might hold the key to dark energy, the mystery that makes up most of the cosmos. But the wild part is, even at the edge of everything, zero doesn't fully arrive. It's like trying to find the bottom of a bottomless pit. Every time you get close, space pulls a trick. So what does all this mean? It means zero is not just a number, it's a limit, a boundary we try to reach, a silence we try to measure. But the closer we get, the more we realize there's no such thing as true emptiness. Even the void is alive. It's buzzing with uncertainty, dancing with probability, filled with invisible patterns. And yet, we still use zero. We write it. We build with it. We plan around it. Because even if we can't fully reach it, we understand what it means. It means start here. Nothing. So far. Let's measure from this silence. Zero is the way we describe what isn't there, so we can understand what is. It's not about erasing reality. It's about mapping it. And that's why physics will never let go of zero, even if the universe never quite reaches it. So tonight, as you drift off, imagine floating in a perfect vacuum. No star,
No sound.
no time. And yet, something flickers. A tiny wave. A whisper of energy. A reminder that the void is never truly empty. And zero, sweet, patient zero, is right there with you. Not as a gap, but as a guide. Let's ask a really big question. What's the meaning of life? No pressure. You're just lying in bed, maybe hugging a pillow, possibly thinking about breakfast. So this seems like the perfect time to tackle the entire purpose of existence. Now, don't worry. We're not going to get too intense. This is the Sleepless Mathematician, not the Existential Panic podcast. But still, there's something interesting about how zero sneaks into that question. Because every time humans try to define life to figure out what it all means, we eventually run into nothing. Not in a depressing way, more like a reset. A clean slate. A starting point. Zero. Let's back up. Some philosophies, especially in Eastern traditions, actually celebrate the concept of nothingness. In Buddhism, the idea of emptiness isn't scary. It's peaceful. It means freedom from craving, from ego, from noise. Imagine your brain as a chalkboard. Zero wipes it clean. Suddenly there's space for something new. Or, maybe, for nothing. And maybe that's okay. In Zen, they talk about the beginner's mind. The idea that when you know nothing, when you're at zero, you're most open to truth. It's not ignorance. It's potential. Zero becomes a kind of wisdom. The wisdom of not knowing. Now, here's where it gets fun. Mathematicians kind of feel the same way. To a lot of them, zero isn't just a number. It's a concept. Something that invites curiosity. Like, how do you even define nothing? If I have a bowl and it's empty, is that nothing? Or is the bowl something? If I take away everything from a room, all the air, all the atoms, is the space itself still something? What about a moment in time when nothing happens? Does that moment still exist? You start pulling at threads like this, and suddenly you're in full philosopher mode. Welcome to bedtime metaphysics. And zero is everywhere. It's in our stories, our language, our sense of beginnings and endings. Think about birthdays. When a baby is born, how old are they?
0.
Day one of life. Not even a full year yet. And yet, that's the start of the journey. Zero means you just got here. Now let's talk about death. Gently, of course. In many cultures, death is seen as a return to nothing, a reset, back to zero. But even then, people argue, is it truly nothing? Or is it something else we don't understand? It's wild how the idea of nothingness can be comforting to one person and terrifying to another. That's the magic of zero. It's a mirror. You can project anything onto it. Fear, hope, peace, infinity, and all it gives you back is stillness. Let's shift gears. In math, there's a famous joke question. What's the meaning of life? The universe and everything? The answer, according to the Hitchhiker's Guide to the Galaxy, is 42. But what's funnier is what happens if you subtract the meaning of life from itself. 42. So maybe zero isn't the opposite of meaning. Maybe it's the balance of meaning. The moment when everything cancels out and you're just here, breathing, thinking, not solving anything, just existing. Sometimes zero is what's left when the math is done. Now let's get weird. There's a theory in physics called the zero energy universe. It suggests that the total energy of the universe, if you add up all the positive stuff like matter and motion and all the negative stuff like gravity and potential, actually equals, which would mean that the universe didn't come from something. It came from nothing. And somehow, it still works, which is kind of comforting. Maybe the universe is like a huge cosmic budget, perfectly balanced, no surplus, no debt, just zero. Now think about your thoughts. The average person has about 60,000 thoughts per day. Most of them are noise, worries, memories, grocery lists, imaginary arguments with a barista who didn't smile enough. But sometimes your brain gets quiet, just for a moment. And that quiet moment, the mental zero, is when you feel most calm. That's not nothing. That's peace. So maybe, at the end of the day, literally, right now, zero isn't empty. It's rest. A soft pause. A blank page. The part of the story that lets the rest of it matter. You started this video with a brain full of curiosity. You might be drifting now, half awake, fully cozy. And somewhere in between thought and sleep, you're hovering near zero. Not doing, not solving, just being, and that's more than enough. Let's take a moment to appreciate space. Not outer space, not galaxies or rockets, just space. The kind between things, the pause in a sentence, the empty spot on a page, the silence between notes in a song. That space, that's design, that's structure, that's zero. Doing its quiet job. Let's start with a canvas. An artist dips their brush in paint, and before they make a single stroke, they look at the empty surface. That's zero. It's not decoration, it's potential. It's everything that could happen, but hasn't happened yet. Now they place a single dot of colour. Suddenly the emptiness has meaning, because the space around that dot, the negative space, shapes how we see it. The dot is only beautiful because of the nothing around it. It's a visual equation.
Something coughing, nothing, balance.
Let's talk about minimalism. The design trend where less is more. Clean lines, neutral tones, open rooms. You've probably seen it in Scandinavian furniture ads. Or that one friend's apartment that feels suspiciously calm. Why does it feel good? Because it's not cluttered. There's room to breathe. Room for your eyes to rest. That's zero in action. Designers call it white space, or negative space. But really, it's the art of knowing when to stop, when to leave something empty. And that takes skill. Anyone can add. It takes wisdom to subtract. Now shift to music. Ever heard a song where there's just one quiet note, and then a pause? And in that pause you're hanging in the air, waiting. That's zero. Composers use rests just as deliberately as they use notes, because silence makes sound more meaningful. If music were just noise non-stop, it'd be chaos. It's the gaps, the zeros, that give it rhythm. Even in jazz, where everything seems wild, the beauty is in the timing. the space between riffs, the breath between beats. Mathematically, this is all about structure. In geometry, we talk about symmetry, balance, reflection, order. But guess what's always in the middle of symmetry? A point, a line, an axis. Usually it's zero. That's the center, the origin. The invisible point. Everything rotates around. It's not flashy. It doesn't move, but it holds the system together. Zero shows up in architecture too. Think of a building's blueprint. There's an origin point, a center of gravity. Everything radiates from that. Even modern skyscrapers, all steel and glass, rely on invisible zeros, load-bearing centers. Weight-balanced design. The building stands because of all the nothing around the something. Now zoom into typography. Ever notice how good fonts aren't just about the letters? They're about the space between them. That's called kerning. A great-looking word isn't just made of letters. It's shaped by the gaps between them. That's zero, again, not adding noise, but guiding the flow. Even in logos, especially the iconic ones, you'll see a careful balance between marks and space. Apple's logo, a bitten apple, floating in silence. Minimal, striking, timeless, because of space, because of zero. Let's go full circle, literally. A circle, the shape that defines zero, is one of the most powerful, calming shapes in the universe. It has no beginning, no end, no edges, just smoothness, simplicity, wholeness. And yet, at its center, an empty point, zero. The mathematical zero is often drawn as a hollow circle, which is poetic, because it represents nothing by being something. The shape itself is elegant. It loops. It holds space. It's used in mandalas, in clocks, in architecture, in ancient art. Even pi, the mysterious number we use to measure circles, depends entirely on the idea of zero. Without a center, without nothing, there's no way to define the curve. And if you've ever seen a Zen garden, just sand and stones, arranged in soft swirls, you've seen zero turned into design. It's not empty, it's peaceful. Mathematicians feel this too, when they solve a long equation, and everything cancels out, when the dust clears, and all the variables vanish, and they're left with a perfect zero. That's not failure, that's beauty. It means balance was achieved, that the math folded in on itself, symmetric, silent, done, a kind of artistic silence. So tonight, as you close your eyes, imagine your room as a design. The edges, the corners, the soft light, the quiet, and imagine the space between things. That's zero. That's where the mind rests. Not in what's there, but in what's left untouched. Art isn't just colour, it's contrast. Music isn't just notes, it's silence. Math isn't just numbers, it's the space between them. And life? Maybe it's not just what you fill it with, maybe it's also about what you choose to leave empty. Let's rewind. All the way back, thousands of years ago, people were counting with sticks, or rock, or little carved bones. No zero, no placeholders, just tallies. 1, 2, 3, 4, 5, counting things you could see. Sheep, bags of grain, wives, probably unwillingly. And in those days, zero didn't even exist. Not just mathematically. People didn't think in terms of nothing. If you had no goats, you just didn't have goats. There was no zero goats, just sadness. Then slowly, things started to change. The Babylonians used placeholders, little markers to show empty spaces in numbers, but they didn't really believe in zero as a number. It was more like an awkward pause. Then the Greeks came along, incredible philosophers, great at triangles, terrified of zero. Aristotle, the original buzzkill, basically said, nature abhors a vacuum. In other words, nothingness shouldn't be real. And so, in Greek math, zero stayed in exile. Meanwhile, over in India, Something beautiful was brewing. Mathematicians started using a symbol, a little dot, to represent nothing. They didn't just tolerate zero, they explored it. Brahmagupta, in the 7th century, laid down actual rules for zero, like 0 minus a number, negative number. 0 plus 0, still 0. And no, you can't divide by 0. Please stop trying. This was a huge leap. Because now, 0 wasn't just a placeholder. It was a real number, a citizen in the math world. But the party didn't stop there. Indian ideas travelled across the Silk Road and into the Islamic Golden Age. Mathematicians like Al-Khwarizmi, yes, the guy whose name gave us the word algorithm, embraced zero fully. They refined it, wrote about it, built entire systems around it. Their number system, the Hindu-Arabic numeral system, was faster, smarter, and more elegant than anything else. And yes, it had zero. But then zero reached Europe. And Europe, in classic European fashion, freaked out. In the Middle Ages, Florence actually banned the use of zero. Seriously. Merchants were forbidden from using it in financial records. Why? Because it was mysterious. Hard to trust. You couldn't see it, couldn't touch it, and anything that invisible was obviously suspicious. Some even said it was satanic, because what kind of number represents the absence of God's creation? The answer, a very useful one. Enter Fibonacci, a brilliant guy who spent time in North Africa, saw how great Arabic numbers were, and came back to Europe like, hey folks, I've seen the future. It's got zeros in it. He wrote the Fibonacci, the book of calculation, and basically reintroduced Europe to a smarter way of doing math. At first, people were like, no thanks, we prefer counting with letters and struggling through life. But eventually, the tide turned. Because zero was just too powerful to ignore. It made math easier, commerce faster, accounting more accurate, science more precise. It made place value possible. Try writing 1000 without zero. You can't. Try doing algebra without it, or calculus, or physics, or computer science. Nope. Once zero arrived, really arrived, it started showing up everywhere. And then it stopped being suspicious, and started being essential. So let's do a quick victory lap. Zero, once feared, is now. In every phone, every computer, every code, in every bank account and budget, in science, engineering, medicine, navigation, in time zones, temperature, GPS, altitude, it's in your thermostat, your calculator, your spaceship, if you have one. It's in the binary that powers the entire digital world, and all that from a number that means nothing. That's the comeback of the millennium. Zero didn't win by shouting, or conquering, or flexing. It won by being useful, quiet, exact. It solved problems that no other number could, and in doing so, it rewrote the rules of math, science, and thought. Now we can't imagine a world without zero. It's so normal we forget how weird it once was. It's the default setting, the starting point, the empty box that lets us organize the rest. And maybe that's the real legacy of zero. Not just as a number, but as a framework, a way to begin, to measure, to understand. Zero lets us define everything else by comparison. It's not the absence of meaning. It's the scale we use to find it. So tonight, as you drift into the soft logic of sleep, remember this. The most powerful breakthroughs in history sometimes start with nothing and end with everything. Okay, let's do a little dreaming. You're in a world where zero never existed. No symbol for it. No concept. Just a missing idea. And at first, it doesn't seem so bad. People still count. They still trade goats. They still forget where they put their keys. 1, 2, 3, 4, 5. So far, so good. But then things start getting weird. Let's try writing the number without zero. How? You could try 100 in words. Or maybe make up a new symbol. But what does that even mean? Because without 0, you don't have place value. Which means 11 isn't 11. It might be 1 and 1, or 101. The difference. Undefined, numbers become slippery. Hard to organize. Math becomes an art project. A guessing game. Now imagine trying to do multiplication without 0. No tens. No 20. No decimals. No padding. Every calculation becomes longer and fuzzier. Spreadsheets would cry. Accountants would scream. Calculators would simply give up and walk away. But it gets worse. Because without 0, you can't write 0 in your bank account. Let's say you spent all your money. Your account is empty. But how do you show that?
You can't write nothing, that's just a blank space.
And blank spaces in banking? Not great. People might think you forgot to fill in a number. Or worse, they might assume it's infinity. Suddenly your bank thinks you have unlimited funds. You try to buy a sandwich. The economy collapses. Oops. Now imagine your phone. It runs on binary zeros and ones. But now there are no zeros, only ones. How does that work? Well, it doesn't. Your phone won't turn on. Your Wi-Fi is gone. You can't even Google why is everything broken? Because computers without 0 are like songs with no silence. Just noise. Try building a digital clock. When does it start? Not at 0. There is no... Does it start at 1 midnight? Nope, that concept doesn't exist anymore. You'd have to create a whole new system of time. And while you're at it, good luck setting your alarm, because 0 is the starting line. No 0? No clear start. Let's try physics. Want to measure acceleration. You need to know when something wasn't moving. That's 0 velocity. Without it, how do you define motion? How do you compare change? You can't. Then you're just guessing. Now take a trip to outer space. You want to launch a rocket. You count down. 3.
And then what?
What comes after? Nothing. Silence. Go. Without 0, there's no blast-off moment. No T the 0. Just confusion. NASA isn't happy. Your rocket explodes sideways. Back to Earth. Now let's talk language. 0 isn't just in numbers. It's in concepts. We say 0 tolerance. Ground 0. Back to square 1. Without 0, what do you say? I have no patience becomes I have a vague absence of unspecified something. Not very catchy. Even storytelling struggles. You can't start a game at level 0. You can't talk about 0 progress. You can't say 0 chance, which is sad, because that's one of the most fun phrases in English. Especially when you whisper it dramatically. 0 chance. Beautiful. Now, let's go deep. Without 0, negative numbers don't work. You can't go below nothing if nothing isn't defined. No negative temperatures. No debts. No thermometer showing how bad your winter is. You just have to say, it's very not warm, poetic, useless, and forget about algebra. Solving for x. X without 0. How do you say x? You don't. You just shrug. And calculus? Gone. No limits. No derivatives. No elegant dances around infinitesimals. Just sad mathematicians and very confused physics students. Modern science would grind to a halt. So would most of engineering, medicine, data, the internet. 0 isn't just useful, it's foundational. Now, here's a twist. Even though 0 seems like nothing, removing it leaves a giant hole. A hole in math, a hole in logic, a hole in civilization. It's like taking out the pause button on life. No reset, no reference, no silence. Without 0, everything is noise, clutter, and confusion. But here's the good news. We do have 0, and somehow, this tiny number, this quiet placeholder, became the root of so much meaning. So tonight, as you drift off, imagine that alternate world again. A world with no zeros,
No clean starts.
no stillness, and then smog. Because in this world, we do believe in nothing. We believe in the power of silence, in the beauty of beginnings, in the circle that holds meaning by holding space. We live in a world that let zero in and became infinitely smarter because of it. So here we are, at the end of a story about nothing. And somehow, that nothing turned out to be everything. We've countered with it. We've feared it. We've worshipped it. We've divided by it, or at least tried. We've used it to build rockets, tell time, and text our friends goodnight. All from a little circle, a shape with no beginning.
No end.
Just a loop, a breath, a pause. That's zero. When you think about it, zero is kind of like sleep. It doesn't do anything dramatic. It doesn't shout. It just holds a space, a soft place to land, a reset, a little vacuum of quiet. Sleep, like zero, is where things stop, but also where new things begin. It's where your thoughts slow down, your body unwinds, your mind organizes itself, invisibly, just like a computer quietly sorting ones and zeros while the screen is dark. And just like zero, sleep doesn't need applause. It just needs to be. Tonight you've followed a number through history. You've walked dusty roads with Sumerians and argued with Greek philosophers. You've peeked into black holes, floated through quantum nothingness, laughed at Roman numerals, imagined a world where time never starts. All because of zero. And now, there's nothing more to do. Just breathe. In, out. No solving, no proving, no thinking, just resting. And maybe that's the final lesson zero gives us. That absence can be beautiful. That nothingness can be enough. That stopping is part of the pattern. We tend to chase things, knowledge, answers, progress, but we forget to pause, to sit at zero, to be okay with not knowing, to say, this is where I stop for now, not forever, just for tonight, because tomorrow the numbers will still be there, waiting patiently, and so will the questions, the puzzles, the strange equations, the undividable mysteries. Zero will still be on every clock, every screen, every page, every quiet moment between thoughts. But tonight, zero is just here to help you let go. So if your mind is still spinning, thinking about Fibonacci, or 0-point energy, or whether the Romans ever did long division, that's okay. Let those thoughts drift. Let them curl up like commas. Let them fade like chalk dust. Zero is here now. It's in the silence between heartbeats, in the space between the sheets, in the stillness just before dreaming. And that stillness, that's not empty. It's full of peace and softness and quiet knowing. Zero is the shape of sleep, a closed loop, a safe circle. So as you lie there, wrapped in blankets, surrounded by nothing in particular, let the day subtract itself. Let the noise round down. Let your mind return to zero. Not lost, not erased, just still, ready to begin again when the time is right. But not now. Now is for floating, for resting, for not doing. Now is for nothing. Good night, dear Zero, and good night to you.